Hey everyone, I'm Mohana, an IB Year 2 student, and in this video, I'm going to walk you through my AI powered project called AI Generated Learning Paths for IB subjects, which I have made for my AI Capstone project for the Kaggle Intensive Generative AI course. And this project is very personal to me. So, as someone who's juggling six demanding subjects, also internal assessments, extended essays, TOK, and stuff, and limited time, I know how hard it is to find the right way to study. So, I built a Gen AI assistant that helps create personalized study plans, especially for subjects like physics HL, chemistry SL, math AAHL, and computer science HL. So what makes it special? I used RAG, Retrieval Augmented Generation, embeddings, multi-agent routing, LLM-powered evaluation, and the Gemini 1.5 Flash model, all integrated within a Kaggle notebook. Let's dive into the code. So uh, I've also explained all of that over here and also the real world impact. So over here, uh, does this cell basically does three things. It installs the Gemini SDK and then imports the Gemini module and a Kaggle helper to securely access the API key, and then it authenticates the Gemini model using the Google API key stored as a Kaggle secret. So why I have used Gemini is because Gemini 1.5 Flash, because it's fast, it's context aware, free in Kaggle, and it supports long token limits, ideal for educational applications. I could have also used ChatGPT or Cloud, but I didn't because ChatGPT's API isn't free in Kaggle, and also Cloud doesn't natively integrate in Kaggle. And so Gemini in this case is kind of open source as well. So now I'll be moving on to the next part. Here also I've explained why I've used what I have used. Um, Here is what I have installed, which is the FAISS module I have used. And I've also explained why FAISS, which is Facebook AI similarity search, which is basically fast, and it is a scalable vector search, and it's needed for chunk search in big PDFs. I could have also used scan or elasticsearch, but then FAISS is optimized for local search. Scan is for Google Cloud based and not ideal for Kaggle. So, which is why I have used this. And then I have used FAISS as well because it's fully open source and it's built for speed and scale. See, so these are some of the libraries that I have used. Uh, FAISS is for vector simulated research, PyPDF is for extracting content from PDFs, and then sklearn is for evaluating. So I've used precision and nDCG evaluation metrics later, which you will see. And here are some uh, variables. So these are the code inputs for the user provides for the planner. Total weeks as in how much time the student has left, for example, for an exam, user background, weekly time, all that. So why did I use these inputs? Because every student is different, and this ensures that the planner adapts to real constraints and doesn't just give generic advice, which is why I've used this. Now I'll be coming to the PDF loading and the chunking part. So this is where I have uploaded my IB subject guides for physics, chemistry, maths, AHL, and CSHL. Uh, Here you are. This is my long PDF. And you can see I've loaded 11,757 chunks over here. So why I have done chunking is because chunking allows the model to be retrieve focused. It only focuses on relevant parts of large documents because large documents can overwhelm the embedding model if passed as a whole. And the chunking method that I used was the simple paragraph based chunking. How it works, I have put it over here, and why I have used this method is also over here. It's easy to implement and it's fast, and it also avoids cutting mid sentences, like unlike the fixed length chunking. Then here is the generate embeddings part. So over here I have used FAISS indexing. Oh, also I forgot to mention for the chunk, I have chunked the contents into 400 tokens paragraph using the semantic chunking, and each chunk is stored for further processing. Okay, now coming back to the embedding part is that I have converted each chunk into an embedding using the embedding 001 model, which is because it's one of Gemini's best available free embedding model for Kaggle, and it converts chunks to numbers. And I could have also used text embedding 005 or OpenAI, but other models are either not supported in Kaggle or they're very costly, which is why I have used this model. And these embeddings are not just document level. I mean, they're just document level. They are not word or sentence level, and they preserve context and flow of the IB concepts like thermodynamics, kinetic theory, all that in physics, just as an example. So then I've indexed them using the FAISS with HNSW. So FAISS is one of the fastest local vector search engine, and it's ideal for Kaggle. And HNSW, which is hierarchical, navigable, small world, and it helps scale up with the fast and accurate similarity search. So why not scan or annoy? Because FAISS is it's optimized for academic RAG tasks and it works fully offline. So that's one of big pluses of using FAISS over here. And I have also mentioned over here why I have used this embedding model, because it's optimized for retrieval tasks, not just similarity but semantic matching. Not it's idea level, not just word level, and it's fast and reliable. And I have the task type that I used was a retrieval document because its purpose built is for embedding chunks of a large source like the IB PDFs over here. So I've explained more over here about that. And here you can see I have indexed again 11,757 documents. Uh, so I've also explained here again, so why I have used HNSW and FAISS, because HNSW, it outperforms the flat index in both the speed and accuracy, and it's especially good for large document sets. And the key parameter I used was the EF construction equals to 40, which controls the graph's complexity. So the higher value gives better accuracy, but of course, the con is the slower indexing. So I've also mentioned which feature and why it works in this project for FAISS plus HNSW. Then I have saved the vector so that it's a reusable RAG pipeline, and also I don't have to reprocess the PDFs every time I rerun the notebook, right? And then I have done the RAG retrieval. Uh, so here I have used the top K document chunks from the vector store. So that is what is being retrieved, which are semantically similar to the query being put by the user. And how this is done, the query is embedded using the embedding 001 model, and then it's compared to the FAISS index using the cosine similarity. And it basically embeds the user query. It retrieves the top 5 most relevant chunks, because I put k is equal to 5 over here using the cosine similarity. And I could have also used top 5, top P or beam search, but then top K is deterministic and you want most, relevant syllabus parts, not a probabilistic spread, because top P is the nucleus, it's over here, the nucleus sampling, and it results in the cumulative probability. So it reaches the P of 0.9. It's good for randomness in text generation, but it's bad for retrieval. It might give you 3 results or 12, which is unpredictable for vector search. There are also some, oh, sorry. There are also some other alternatives which I've mentioned over here that you can see in the notebook. Uh, Now I'll be moving on to the drag plus the Gemini with the contextual instructions. So here I used Gemini 1.5 flash model again, and the retrieval augmented generation. The user question plus the top syllabus chunk, which equals to the inputs prompt. Then the Gemini then generates a custom learning path or plan or explanation, and then it's formatted to stay aligned with the IB syllabus. So RAG just makes sure Gemini doesn't hallucinate, and it stays grounded to the real IB content. So I've also mentioned here why I have used Gemini 1.5 instead of Gemini 2, because it's still being rolled out and it's not probably fully supported in Kaggle. And there are also some other reasons. So here is my intelligent agent, router agent, and I've given the prompt over here. And I've also given the purpose. So here is a function as well for the router agent, which I'll call later in one of the other code cells. So it's basically to generate personalized study plans via the Gemini directly. So if it's a plan, it sees the keywords. If it's a plan, it sends it to the generate learning path, the function you just saw. And then if it's not, if it's something else, then it sends it to the generate answer with RAG. So if you have any question related to I, basically that. And then here's the evaluate retrieval. So I've used the precision and the nDCG normalized discounted cumulative gain to measure the relevance and the ranking quality, which is better than the precision alone. And these metrics, they just evaluate the retrieval step, not Gemini's generation. It's getting tested whether the search is retrieved for the right material before passing it into the LLM. So this is crucial to evaluate how smart the retrieval engine is. So there is no point in fancy generation if the base information is wrong. And then here is the drop down menu with the widgets and everything. So I couldn't make a GUI for this separately in Streamlit because Kaggle doesn't allow that. So I thought of making something small in Kaggle itself. And here is a small kind of guideline for the user so that when they ask a question, uh, they would know what kind of questions should users ask to get the desired or like good answers. So here it is. I also give a example query. So here I have put my question, my subject. You can see the drop down to over here. The 4 subjects are here. I have 4 weeks before my physics HL exam. I struggle with electricity and magnetism. Please give me a study plan focusing on the practice-based learning, because some people might be concept-based, might be looking for more of concept-based. Some people are more thinking of more practice-based. It depends on student to student. So here the RAG can give you week 1, week 2, week 3, week 4, and then there it goes. And here is my evaluation, the LLM AutoRater, which is Gemini versus Gemini. LLM is judge over here. So I asked Gemini to rate this generated output based on some criterias, which is given over here: accuracy, completeness, overall score, relevance to the syllabus, and it's out of 5. And for the RAG output, which we found right now, it got overall score of 3.67. It could have been better, but that just shows that even my LLM AutoRater is giving good feedbacks. And I could have used human evaluation in loop as well, but it's quite time consuming and slow, which is why I didn't. Here are some of the other, this is a table to show that why I didn't use traditional metrics like blue, rouge, or nDCG. And you can see that over here. So I'll be adding the link to this notebook under my video, or probably the GitHub link. And thank you for watching this video, and I hope you enjoyed watching this video. Thank you.